In order to satisfy the op-amp's need for a V plus supply and a V minus supply, we needed to construct a dual power source. From the 12-volt source applied, two resistors, in this case two 1 kiloohm resistors, were hooked up in parallel to the positive and negative branches of the source. The two resistors were then connected to the same node on which a virtual ground exists. These positive and negative voltages were used as rail voltages for the op-amp. It is important to use resistors of the same value for this step. This image shows our circuit diagram. For simplicity's sake, we decided to use only one inverting op-amp for our circuit. A negative voltage works, however it can cause some problems. But because a negative voltage would suffice, we chose to use one rather than two inverting op-amps. As can be seen in the picture, our V input runs through the input resistor and into the negative branch. The VI in this case comes from the microphone or MP3 device that the circuit is hooked up to. The positive end of the op-amp runs to ground. The positive and negative 6 volts that can be seen from the op-amp are the rail voltages established by the voltage divider in the previous image. The output of the op-amp has a feedback loop and a feedback resistor. The feedback resistor is the potentiometer used to adjust the volume. By adjusting our potential, we can adjust the gain of the op-amp and in turn adjust the volume of the output. Here are the calculations used to find the output voltage in terms of the input voltage. The equation was derived using nodal analysis, where node A and node B are the positive and negative terminals of the op-amp respectively. Assuming this is an ideal op-amp, the voltage drop at nodes A and B would be the same. Using Kirchhoff's current law, the currents branching off of and going into node B can be summed to zero. Since this is assumed to be an ideal op-amp, no current runs through the op-amp, meaning I3 is 0, hence I1 equals I2. With this info, we can find that VI over RI is equal to negative VO over R potential. This equation comes out to input voltage times gain equals output voltage. This is our final circuit constructed on the breadboard. Two ICs were used instead of one for left audio and one for right. The capacitors shown are attached to the voltage divider in order to beef up the power supply for use with the op-amps. The input is connected to a cut-in-half cable, one end leading to the headphones, the other leading to the MP3. The aforementioned cable was cut and stripped to isolate its components, one wire leading to ground and the others leading to the op-amp. We had to solder the wires onto the existing ones and insulate it with electrical tape. This is the potentiometer used to adjust the gain. We used a 50K potentiometer in conjunction with a 10K resistor to avoid overly touchy gain. Here's a closer look at our circuit. We used two inverting op-amps, one for the left audio and one for the right audio. Here is the voltage divider. We have two 1 kiloohm resistors hooked up, and in parallel with them we have two 1000 microfarad capacitors. The same is true for the other side, or the left audio. All of this is hooked up to a 50K potentiometer. Turning the knob adjusts the gain and in turn adjusts the volume. This potentiometer is hooked up to the op-amp, both left and right audio, and the op-amp is hooked up to a cable, which is fed in as the input from the MP3, and the output is fed through the same cable that was split